Beginning. Hello, everyone. Good evening. To authors and invited guests, welcome to Technical Session 9B. Myself, Ishita Sauryan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information Communication Technology for Competitive Strategies, ICTCS 2024, Jaipur, India. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held day before yesterday in Jaipur, India, and the virtual event is being held through Zoom today and was held yesterday, that is 20th and 21st of December 2024. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for question and answer. On 7 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce to you all the chair for this session. We have with us Dr. Chitali Shivale, who is a distinguished academician and researcher, currently serving as an assistant professor at Vishwakarma Institute of Technology, Pune, India. She holds a PhD in computer science and engineering and has over 12 years of rich experience in teaching, research, and academic leadership. Dr. Shivale has made notable contributions to research with more than 30 publications in reputed national and international journals. She has served as a research co-guide for several academic projects and actively engages with the global research community as a reviewer and session chair in numerous international conferences, attending over 20 such events. We welcome you, ma'am.
Yes, ma'am. Thank you.
We'll be proceeding with the paper presentations for the session. The first presenter I'd like to invite Mohana Chelvan with the paper titled A Review on Recent Advances in Privacy Preserving Data Analytics and Big Data. So if you're ready, then you may start.
Yes, ma'am. I will start. Can you
Sure.
hear me?
Yes, sir, you're audible.
Good evening, one and all. Present here. My name is Mohan Chelvan. I am research scholar in Department of Information Technology, Dr. MGR Educational Research Institute, Chennai. The co-author is Dr. B.N. Rajavarman. He is professor there. My paper ID is 121. My paper title is a review on the recent advances in privacy preserving data analytics in big data. Okay. In today's every organization collects data from our there is everyday activities like all the transactions, and then we are using smartphones for everyday activities. So all the organization collects our data for their then use the data for the mining patterns, for getting some strategic information for the improving the that is strategies that is the organization welfare. But our data mostly contains private data, so it should be preserved before it will be being mined by the third parties. So privacy preserving is very important. And nowadays, it is not only the structured data, most of the data is unstructured. And also it is the huge volume of the data. And so we need to, that current privacy preserving techniques are mostly worked with the structured data. But in the big data, it is most of the data is unstructured and also the huge amount of data. So we need to have, and that is the less explored topics, that is research, is the big data analytics, big data privacy preserving techniques. So I have surveyed I have worked on in literature survey. I have go through some papers which are recently published in the privacy preserving big data analytics and analyze the techniques. The first one is by the VP Rao and Mehta. It is a scalable K-anonymization method. It works on the map reduce using the Hadoop technology. It is worked with the K-anonymization conditions. So normalized cardinal penalty is used to calculate the loss of percentage of data. It is uh, less easy compared to the other, less complex compared to the other similar methods. But it is the information. There's a lot of information loss in it. The other is improved L diversity. In the K-anonymity method, there is a background knowledge attack or the linkage attack will be there. So we can improve with the L diversity. It is that paper is by the BP Mehta and Uday Pratap Rao. So it is published in the Journal of King Saudi University Computer Information Science. So along with the K-anonymity, it works with the L diversity method also. So the K-anonymity method will make it as a anonymous the quasi identifiers, and sensitive attributes are then L diversified with the L number of values. So it improves the privacy of the privacy preservation techniques. That is improved compared to the k-anonymity. L diversity has the improved technology. It will prevent the linkage attacks, but it is implementation is very complex compared to the k-anonymity method. Also, the data utility will be reduced. So another is the implementation of the big data privacy preservation. It is in the conference paper by the Ganesh Dugar Puri and Harita. It is the combination of generalization, slicing, anonymization, L diversity, K anonymity, and also one-way hash function. There is the combination of these techniques. So it is very complex to implement all the things in the big data scenario. In the ordinary, that is in the structured data, the big data scenario, there is a huge amount of data. It works on the MapReduce algorithm using the Hadoop technology. So implementing all the techniques in the Hadoop, in the MapReduce techniques in the distributed computing, it is very complex to implement it. Also, the information loss is very, there is a lot of information loss. But it improves the privacy preservation techniques, but the implementation is very, that is where it takes long processing time. And another technique is the privacy preservation techniques, the big data analytics by the Shekawat, Sharma, and Kali. It is the it mostly uses the cryptographic techniques, homomorphic encryption techniques, ordered privacy encryption techniques, attribute-based encryption techniques. Mostly, if you use the encryption techniques, the data utility is drastically reduced. Also, it is very complex to implement the encryption techniques in the big data scenario. So it is very less, not very good to use in the big data scenario. Another one is towards the privacy preserving big data. It is B. Mehta, UP Rao, and M. R. Gupta and Kanti. It is used that unstructured data will be tagged with the converted into structured data, and again the scalable k-anonymity method is applied on it. So it will be work with unstructured data. First, the unstructured data, that is semi-structured data, will be converted into structured data by the tagging, by using tagging like the XML like tagging, and then it will that scalable SK will be applied on it. It is also very complex to implement. Actually, my research problem is in today's big data scenario, there is not only the huge amount of data, but also dimensions of the data also increased manifold. So we need to, if we apply the data analytics, we need to select only relevant attributes only. So for that, feature selection is very important topic, because we remove the irrelevant data, then only it will be very effective. That data mining will be very effective. For that, feature selection can be used. So if you apply the privacy preserving techniques in the big data, it will be drastically that is the changes the characteristics of the data set. So if you change the characteristics data, it is directly linked with the feature selection stability. Feature selection stability is an important topic of the research in recent times, because if the small perturbation of the data by the some other techniques like the privacy preserving techniques, it will that the next iteration of the feature selection will select completely that is other set of data, that is different set of data. So the feature selection is directly linked with the data utility. If the each iteration for the small perturbation selects the different sets of data, then the researcher not able to rely on his research findings. So feature selection stability is directly linked with the data utility. So we need to do research for the privacy preserving techniques which not much affect the statistical properties of the data. Then only the feature selection stability can be improved. That because feature selection stability is the hot topic of research in today's research field. So feature selection stability is directly linked with the data utility. Feature selection stability is previously thought as it is algorithm dependent, but recently by some researchers have concluded that it is the mostly data set dependent, but partially algorithm dependent. That is minimal with the algorithm dependent. So we need to do research in the privacy preserving big data analytics, which will be less effects on the characteristics of the data. So then it will be improve the feature selection stability and the data utility. Actually, this is my research problem. So I have analyzed a few research papers about the feature selection stability. That is the privacy preserving techniques, and how it affect the feature selection stability and accuracy. Data utility is my research area actually. This is my research problem. Any questions?
Okay. So have you checked any feature selection methods up till now?
That is
Means
information gain.
any, let's say if you have a data set, so how will you categorize that which features to be selected according to the problem statement or something? Like, have you implemented this system, whatever research problem you have?
Just now I am collecting the data set and everything, ma'am. Just research review is over, so I start working on that. That I have worked some feature selection techniques. That the information gain is one feature selection technique. Some techniques I have applied. I start working on.
Okay. Okay. So you have collected the data. So how you are collecting the data for this particular purpose? How many
Because
sources or
in the privacy preservation, we generally get select the data from the from the public data. So you need to preserve the privacy of the, that is some census data like that we need to collect from UCG repository, census data.
okay. Okay, okay. Okay, thank you.
Thank you, ma'am. Thank you.
Thank you, ma'am. Thank you, sir. We'll be proceeding with the next paper presentation. I'd like to invite paper presenter Pooja Tiwari with the paper titled Analyzing the Growing Role of Smartphones and Mobile Apps in E-Commerce. Ma'am, if you're ready, then you may start with your presentation.
Sure, ma'am. Am I audible to everyone?
Yes, ma'am, you're audible.
Thank you so much. Good afternoon, everybody. Let me share my screen first. Visible?
Your screen's visible. Yes, ma'am, the PPT is visible as well.
Okay. Okay. So good afternoon, everyone. My name is Pooja Tiwari, and today I'm going to present on the topic of analyzing the growing role of smartphone and mobile apps in e-commerce. Coming to the introduction part, as we all know that e-commerce is also known as online shopping, and in today's world we all are dependent on online shopping as well. So e-commerce is basically a platform that facilitates the entire process of buying and selling products with the help of internet, which basically satisfied both the parties, be it a seller and the buyer. Now, the basic factors which are required to do this buying and selling process over the online platform is, first, basic level of education has to be there on both the end, be it a, as I said, be it a seller or a buyer. They have to be basically educated in order to use these online platform. Secondly, online payment portal system should be there. They should be supported by the online payment portal system, and the internet facility has to be there from both the ends. Now, what this e-commerce helps us to reach, it helps us to reach the global market because it reduces the geographical barriers. At the same time, it increases the competition amongst the different organization on a global level. Now, we make sure that these e-commerce platform, it has to be very user friendly, because in order to tap the maximum number of population, it is extremely important that these apps, whatever apps or the smartphones which are basically we use, it has to be user friendly so that every kind of public, they can use these platform. And nowadays what happens is organization have also realized the fact that how important it is to maintain the relationship with the customer. Now, how do they do that? They basically collect all the informations, customer informations, through the mobile apps. Now, whenever we download or install any app, we will be asked about our basic details, our name, email address, phone numbers. Now, these are what? These are our personal data, which is basically going to these particular apps. Now, these data can be manipulated. Data can be, utilized for their own purpose. The company can use our personal data for their own purpose. Now, how do they do that? Now, in different occasions, be it our birthday, be it our puja vacations or new year's, we get the pop-ups, we get the text messages that wishes you a very happy birthday. Or for that matter, they also update time to time. They update us about their product offers, their different product services. So we will get notified through these things, and this is how they maintain a very good relationship with the customer. And we can say this is the most cost effective manner of maintaining a relationship with their customer. Coming to the objective part, now in my study there are two objectives. First is to identify the factors which influences the customer continuous usage intention of mobile apps and smartphones in context of e-commerce, and to analyze the impact of smartphones and mobile apps usage in e-commerce. Moving on to the next part, which is literature review. Now, this online platform, basically we all know it enhances the growth of e-commerce business. Now, with the extensive literature review, I have came to the conclusion that people utilizes this online platform for buying and selling purposes with the help of different mobile apps which are there in our respective smartphones. Now the question is, why we are leaning towards this online shopping rather than offline shopping? First of all, there are majority of factor. I am focusing on three major reasons why we are leaning towards this online shopping. The first is search convenience. Now, what do we mean by search convenience? Search convenience is basically how effortlessly I can gather information about a particular product or a service. Now, through this e-commerce platform, we can search anything or everything out there in the market. So it is very convenient for us to search the product or a specific product or service. The next is access convenience. Now it has become very smooth process for us as a customer to reach out to our service provider. We get to know that who are providing these services or product, and when are we going to get our product. So every information will be there. So that is one more convenience. And the third one is evaluation convenience. Now evaluation convenience can be defined as the every detailed of the particular product and services which are being provided over there on the online platform. Apart from that, as a customer, we tend to, before doing the final purchase, we tend to evaluate the basic details of the product. At the same time, we want the reviews from different customer. Now getting reviews offline is a bit difficult. I'm not saying it is not possible, but it is difficult. But if we see in an online platform, be it a Myntra, Amazon, Flipkart, which we use in our daily life, we see that in every product details, after every product details, there are customer reviews. Through those reviews also, our decisions matters. Whether we are going to buy it or not, it matters. It basically, we basically depend on those kind of reviews. So we get these reviews. It is very convenient for us to get those reviews on an online platform rather than the offline platform. Now, one more thing is, unlike offline setting, online platform offers a range of product and services to showcase, which basically helps as a customer to reach to a particular decision making. So it basically increases our efficiency in decision making. Whereas in offline setting, there is a space constraint where they cannot show each and everything in their shop. Whereas it is possible in the online platform. Now, these mobile applications are designed as per our customer needs. This app shows specific product or services according to customers' frequent search history, which helps in customizing services and enhances customer satisfaction. Now, what we search in Google or what we search in these e-commerce apps, they are being stored, and what we search, it will be shown in different apps which are related to, like, the information which we share in different apps, they all are interrelated. So if, say for example, in a Flipkart, if I have searched for a water bottle, then if I open Facebook or Instagram, I will see the different types of bottle I will be seeing in the advertisement part. So these are all interrelated. So this means my search histories are being recorded, and they are providing us the customized service according to our previous search history, which enhances our customer satisfaction. We don't need to type everything, because they will give us those product and services. They will show us which we are looking for based on our previous search histories. Now, coming to the efficiency part, in the context of customer purchase decision, efficiency can be defined as a given fixed set of resources allocated to decision, the maximum satisfaction obtained by the consumer from a consumption decisions. Now, these smartphones and mobile application facilitates the consumer online purchasing decision efficiency. How? By avoiding wasting time, effort, and cost. Through use of these mobile application, through use of this e-commerce, we basically saves our time, we basically saves our effort, and at the same time, we also saves our cost as well. the increased level of these efficiency has a major factor to determine whether we are going to continuously use these type of e-commerce platform, or for that matter mobile application or not. It is a detrimental factor for us as a customer. And user satisfaction is again one of the item which I have seen through this literature review. It is extremely important. Now, how do we define the user satisfaction? Now, after every purchase, we have this experience of positive and negative. If the person is feeling a positive experience after purchasing any product or services, then it can be considered that the user has got the satisfaction. And satisfied customer, I'll tell you, this is the most efficient way to reach to a maximum number of people, because if the customer is satisfied, they will do the word of mouth promotion, which is the most effective way of advertising your product. And if the customer are satisfied with a particular mobile application, or for that matter with this online platform, they will be motivated to use them further, because they have developed this positive attitude towards these applications. Now, this is my hypothesis development. These are the 4 proposed hypotheses which I have proposed in this particular study. This is the hypothesized research model. Coming to the research methodology part, for my study, I have used both primary and secondary data in order to collect data. And descriptive research design and online cross-sectional survey was used for my study. The duration of the survey was from May to July 2024, and the sample size was 300. Now, I measure the responses with the help of 5-point Likert scale, where the strongly disagree and strongly agree depict 1 and 5 respectively. The sampling techniques which I have used for my study is convenience sampling technique, which comes under non-probabilistic sampling, and SPSS 28.0 was used for the data analysis part. These are the demographic profile of my study. Coming to the measurement model, which basically tests my reliability and validity testing. So as you can see, there are 4 items, 4 construct in my study, which are user satisfaction, online information processing convenience, decision efficiency of online shopping, and continuous usage intention, wherein the
I'm really
composite...
sorry to disturb you, but I'd like to remind you of the time limit.
Okay, sure. I'll keep that in mind. I'll try to finish as soon as possible.
Sure.
So this CR, which is composite reliability, it ensures the internal reliability of these items, and it is within the range, which is more than 0.7. And the AVE, which is average variance extraction, is basically it falls under the given range, threshold range. These are the structural model which basically test our hypothesis. If you can see the p-value, all are less than 0.5, which shows a significant value. Coming to the discussion part, from this particular study, all the 4 hypotheses which I proposed, all of them were supported. So it has been seen that there's a positive relationship between the information processing convenience and decision efficiency, which basically implies that the online marketers can utilize e-commerce to improve the decision efficiency of the customer, which basically helps to cater the customer in a better and smarter way. And all the other three hypotheses was basically supported. Coming to the implications part, now this study has both the managerial and industrial theoretical implications. Coming to the theoretical implication, basically it enhances the understanding of e-commerce marketers about how smartphones and mobile apps can influence the decision-making process of the consumer. This study also sets a guideline for the future researcher to know the importance of mobile technology role in order to engage customers. Now, in this competitive world, it is extremely important to retain our customer because they have multiple options to look for. So in order to retain the customer, we can also engage our customer with the help of different online influencers and make them the potential customer into our existing customer, and the existing customer to the loyal customer with by engaging these customer with the help of different mobile app
Excuse me,
activities
ma'am.
and smartphones.
Really sorry to keep disturbing you, but can you please go to the conclusion part?
Yeah, sure.
Yeah.
So these are my limitations and future scope, and this is my conclusion part. So in this particular study, I have concluded that in order to determine whether the person or whether the customer is going to continuously use the mobile app or e-commerce is highly dependent on whether the person is satisfied or not, whether their decision efficiency has been increased or not, and how much convenience they are getting by using these mobile apps and smartphones. And in my particular study, all of them were supported, and each factors and each construct having the positive relationship with each other. So this is all about my study. If you have any question, you can ask me.
Yes, ma'am. What was your problem statement?
The problem statement was to identify, ma'am, that whether what are the factors basically which determines that whether a customer is going to continuously use these smartphones and mobile apps uh, in order to do anything, like if they are doing business or if they are doing online shopping, whether they are going to continuously, whether they have this intention to continuously use these mobile apps or not.
Okay. So your paper title is same, right?
Yes. Yes, ma'am.
Okay. So what kind of primary and secondary data you have considered for the study? As you have written in your this thing slides, right? You have
Yes.
considered the primary and secondary data. So what kind of primary and what kind of secondary?
So, ma'am, if we see the primary data, so I have basically formed a questionnaire, and I have circulated with the help of different WhatsApp group and emails. So, from where I have got the result of primary data, and from secondary data, I have studied different papers and different literature reviews from different papers and journals. So, both the primary and secondary data have been used in my this particular study.
Okay. Any statistics do you have that
Yes, ma'am.
the
We
smart?
have used SPSS 28.0 for the data analysis part.
Okay. No. I'm asking that you have you actually want to show that you have studied the growing role of smartphones and mobile apps, right?
Yes, ma'am.
So any percentage you know that how much it has been increased from the last year to this year or something like that?
Ma'am, we have seen it is exponentially growing, and in future also we all are depending on this. Still, we are dependent on the smartphone and mobile apps, and it is the trend is like exponentially. It is growing. So there is no.
Okay.
But I would not recall the particular percentage, but it is, ma'am, growing. It is trending.
Okay.
Okay, ma'am.
Thank
Thank you. Thank you so much, ma'am.
Thank you, ma'am. We'll be proceeding with the next paper presentation. I'd like to invite paper presenter, just a second, paper presenter Karthik K with the paper title Categorization of Hyperspectral Images Covering Lands, Feature Extraction Using Decision Boundary with Convolutional Neural Network. So if you're ready, then you may start with your presentation.
Yeah, yes, ma'am.
Yeah.
Yeah, good afternoon, ma'am. Whether my screen is visible?
Yes, sir, it's visible.
Thank you, ma'am. So thank you for this given opportunity to presenting the paper in that ICTS conference. So I'm in my research title is Categorization of Hyperspectral Images Covering Lands and Future Extraction Using Decision Boundary with Convolutional Neural Network. Along with my co-authors are Mr. Jagan, Dr. Pandiraja, Dr. N. Deepa, and then myself. So, in this research article, objective of this research article is to have to find and then identify that hyperspectral images and covering lands. What are the lands and then the images that behind that in the particular images? We are going to identify that with the help of this future extraction and then deep learning algorithms. You have to covering that lands. What are the slides that will be available in that hyperspectral images? We are going to identify that. That is our objective of this. First thing, we are going to using that hyperspectral imaging for this particular research or titles. We have to collecting that hyperspectral images. With the help of these hyperspectral images, we are going to find out that identifying that materials and then objects will be available in that particular images. We have to collecting that spectrum of images with help of this machine learning, deep learning algorithms. We are going to extracting that. We have to easily identify that. This is the way we are going to working on that. we have to review that related works doing in that earlier for our research supported us. First thing, we are going to find out that hyperspectral image classification based on that stacked concentrative autoencoder combined with adaptive spectral spatial information. So this paper having that some merits and then demerits of that. First thing, we have to analyze that what is the merits available in that research articles. So the paper having that ambiguity of the spatial structure of that information in the hyperspectral images. So this is having some huge advantages of that particular research, but it's having some demerits of that. We have to analyze that classification is not going to be improved. So the classification problem area, they have to be improved. That. So likewise, we are going to analyzing these research articles. We have to review that a number of papers, good journal reputed papers. So before after finding that related works, we are going to identify that earlier research having some problems. So these are the related problems we are going to find out in that earlier researches. First thing, we are going to analyze that computational complexity, and then computation complexity is high, and then irrelevant features are extracted. We have to extract that some information from that data sets, means it is having some irrelevant features and then irrelevant informations we are going to extract it in that earlier researches. And the next one is we are going to identify that dimensionalities can be in the high because of that exact information, exact locations we are not going to be fetching that particular data set. So that's having some problems in that earlier researches. And then classification accuracy is compared to that some versions, it's going to be low. That so we are going to consider these problems in that our research areas. So these are the problems we are going to find out that research. So this is after that finding out that the problems, we are going to improving our research areas. We are going to consider this is a proposed system architecture. So first thing, we are going to taken from that hyperspectral images, we are going to doing some pre-processing. So using that pre-processing methodology, we are going to converting that images as a grayscale conversion, and then median filters we are going to using that. After that, we are going to removing that noises in that particular images. We have to using that neighboring pixel analysis, and then decision boundary, and then future extraction algorithms. So this is going to be helpful for that extracting that images, that original informations. So after that, we are going to extract that information. So after that, we are going to given that input to that for that classification. That means layering construction CNN approach, and then land classification algorithms. So after that, we are going to analyzing that exact image information from that particular images. So what are the land areas, and then what are the buildings, what are the trees that's going to be available in that particular images in that hyperspectrums. So we are going to easily analyze that. So this is the way we are going to proposing that our architecture. So what are the work we are going to done, and that things we are to explain one by one. First thing, we are going to see that image acquisition. We are going to collect the data sets, we are going to analyze that. So after that, we are going to pre-processing, and we are to using the median filter algorithm. So we have to given that RGB values for the median filter algorithm. So it is going to be doing that hyperspectral images using that grayscale conversion methodologies. So it's going to be converting that images. After that, we are going to extracting that features of the particular images. So you have to using that decision boundary, and then future extraction values we are going to using that. Finally, we are going to classify that images. So where the water, where the trees, and then grasses, and then roadways will be available in that hyperspectral images, we are going to using to classification algorithms. So next, we are going to see about that our implementation area, final results, how it's going to be given that our algorithms using the decision value and then convolutional neural networks. First thing, we are going to analyzing that the shape of that images, so that the images will be exactly identified that where the buildings and then trees and then roads will be available in that particular images. So the final results of that our project is be given into that. The dark green, the roadways will be given into that red color. We have to using that RGB colors for the different colors for the different yellow perspective objects. First thing, we are using that red color for roadways and then buildings, and then second one, blue colors we are going to using for water bodies, and then dark green we have to using that trees, and then light green colors we have to using for that grasses. So these are the way we are going to extracting that information from the hyperspectral images. So after that, we have to working on that our research areas, that our algorithm will be given that some good results, accuracy results in that comparing to the previous results. So we have to be extracting that information and more accurately using that convolutional neural networks, and then feature extraction, and then decision boundary algorithms. So that decision boundary algorithms will be helpful to accurately predict that areas and then objects where that should be available in that hyperspectral images. Thank you.
Okay, which classifier you have used?
We have to using that feature extraction and then decision boundary algorithms. We are going to using that feature extraction.
Yeah, but you also said no, you are going to classify the images. So, which classification algorithm you have used, or which classifier you have used?
So we have to be classifying that images. We have to identify that images through that deep learning classifiers. Ma'am, see, a convolutional neural network will be classify that images. So first thing we
Okay,
are
how
going
many
to,
layers are there in CNN?
so inputs a layer, and then feature extraction, and then output layers will be there in that.
Okay, so how many input layers you are going to have you used or you are going to use?
We have to using that 5 layers, ma'am. 5 layers of informations we are going to providing that based on that data sets we are going to feeding that informations.
Okay, okay, no problem. Thank you.
Thank you, ma'am. Thank you.
Thank you, ma'am. Thank you, sir. We will be proceeding with the next paper presentation. I'd like to invite paper presenter Shri Vignesh Manoj Kumar with the paper titled Collaborative Diffusion with ChildNet for Personalized Facial Editing, Integrating Genetic Information. So if you're ready, then you may start with your presentation.
Yes, shall I please share my screen now?
Yeah, sure.
I've sent the request. Yeah, is it visible?
I don't see it, but you can just try once more and you'll be able to share the screen because I've stopped screen sharing myself.
Okay.
Yeah.
Yes, is it visible now?
Yes, sir, it's visible.
Yeah, 1 second. Yeah, so good afternoon, everyone. Myself, Vignesh, and I'm thrilled to present our work titled Collaborative Diffusion with ChildNet for Personalized Facial Editing. This project explores integrating genetic data to create photorealistic, age-progressed facial images. We achieved this as a group of 6. So here are the group members in this slide. Facial synthesis technology has immense potential, but current methods often lack realism and genetic accuracy. Our motivation stems from addressing these gaps. By combining ChildNet and collaborative diffusion, we aim to push the boundaries in forensic science, gaming, digital media, and entertainment sectors as these fields demand lifelike and genetically coherent facial predictions. This is our literature survey. From taking a good look at it, we came to find that traditional methods like GANs and autoencoders provided high quality image synthesis, but struggled with diversity and realistic genetic integration. Recent advances such as diffusion models improved synthesis quality and training stability. However, challenges like cross-model learning and high-resolution generation persist, which our work addresses by combining ChildNet and collaborative diffusion. So this is the architecture of our model. So we take the parents' images as input along with the gender of the desired gender of the child that has to be created and the age group. So these parents' images are encoded into Latin codes using an inversion encoder. These Latin codes are passed to the kinship module. The kinship module interpolates genetic features and coarse facial traits to generate the most probable representation of the child's appearance. Then the age and gender manipulation module refines this latent code to match the desired age and gender specification, which is given as input, and which is then decoded to get the output child image, as we can see here. The child image is then transformed into a segmented face marks where key features like the eyes, nose, and mouth are isolated. This mark serves as an input for the collaborative diffusion model along with an additional textual description provided by the user. In the collaborative diffusion model, multiple unimodal diffusion models collaborate using the segmented mask and additional modalities like textual descriptions. These models refine the image iteratively through a process of denoising, where random noise added to the image is gradually removed to produce a lifelike output. A critical component here in this collaborative diffusion model is the dynamic diffuser, which predicts how each model should contribute at each step of the denoising process. This ensures all modalities, whether genetic, visual, or textual, are harmonized and created, and the image created is a highly realistic image. So these are the outputs which we have generated from our model. So these are the parents' image and the real child in her 20s, and the synthesized child we are expecting out of 30s, like middle age 30s or 40s. So that's what we have created. And this is the output based on the genetic ratios and the age group. And here we have the next process, which is the collaborative diffusion model. So we create a segmented mask out of the target image, and then we give a text such as she's an young adult or he has a beard, so that the text can convert it to a finally generated diffusion. So the result, this is the performance metrics and model analysis. The results highlight our framework's ability to create genetically influenced facial images with exceptional detail and realism. Our model outperformed existing methods in key metrics such as Earth movers distance and histogram-based similarity. So our model also explores ethnic factors such as whether if he's British or Indian or Asian, all those factors. So here is an image of the segmented mask with the same segmented mask and same input text that this man has beard of medium length and he's in his 30s. We have generated 3 different ethnic images. And all those images are proved with the Earth movers distance and histogram-based similarity. So I would like to conclude by saying that our framework opens new avenues in multiple fields, from forensics to entertainment. In future, we plan to enhance the model's applicability across diverse populations and integrate explainable AI to make genetic editing more transparent and user-centric. And these are the references which we use to do this project. Thank you.
Okay,
Any
so
questions?
yes, what amount of data set you have considered to convert this images or your resultant to get the resultant?
Yeah, so dataset, we use the NOK dataset for its high quality images and comprehensive family-based data, which would help us enable the effective genetic and facial feature model.
Okay, and the features or attributes which you have selected is it the actual data what you have considered, or you have selected only somewhat attributes out of those data set available with you?
Like attribute in the sense, like is it the genetic features or the ethnic features which you are considering?
Yes, I'm asking about the genetic features which you have considered.
Yeah, the genetic features, the dataset contains the images of real parents and their child, and we use that dataset to train our model, and our model will give the output of any input images which we give as parents, and we are comparing the ratio with other models, whether our model is more successful by calculating Earth movers distance and histogram based.
Okay. Okay, thank you.
Thank you.
Thank you, sir. Thank you, ma'am. We will be proceeding with the next paper presenter. I'd like to invite paper presenter Deepika Gupta with the paper titled Comparative Analysis of Deep Learning Approaches for Lung Segmentation in X-ray Imagery, a Comprehensive Study. Ma'am, if you're ready, then you may go ahead.
Yes, is my screen visible to everyone?
Yes, ma'am, it's visible.
Okay. Yes, a very good afternoon to everyone. I'm feeling great to present my paper in ICTCS 2024 conference. The title of my paper is Comparative Analysis of Deep Learning Approaches for Lung Segmentation, X-ray Imagery, a Comprehensive Study. So my co-author is Dr. Subhadon, ma'am. And these are the index of my presentation. And let's switch on the research gap and the objective. The research gap of my implementation was that the segmentation of the lung images often fails to accurately delineate the result or accurately identify the ROI of an image, which reduces the classification performance. So if you want to increase the classification of any disease present in the patient, so the segmentation is required. So the segmentation accuracy will be increased using some better techniques. So here I have used a unit, which is unit and the hybrid segmentation approach, which enhances the classification accuracy and improve the more precise results. So let's switch on the introduction part. As we all know that the medical reports are a very critical document of a patient by which a doctor can analyze the patient situation and he will treat according to that. So it's the input, whatever the input is given to the image, means whatever the patient has disease anomalies is present in the patient can easily identify. And there are many kind of modalities are present like CT, MRI, PT, X-ray. Here I have used X-ray imagery for lung segmentation purpose. And in this, I have used a lung TB dataset for the segmentation purpose. So let's introduce about what is TB. And we have a part in our body that is lungs, which is a spongy organs present in the human chest, which inhales oxygen and release CO2. So the tuberculosis, which occurs in the lungs, is a disease which is a main cause of death. Early symptoms are breath storage, cough, chest pain, voice change, sputum color change, and the blood coughing. So these are the symptoms of this. I have done a literature survey on this, and there are so many segmentation techniques which are available. Pre-trained models are available like AlexNet, ZFNet, VGG16, GoogleNet, RescueNet, DenseNet, FCN, VNet, UNet. There are so many pre-trained models are available for the segmentation. I have used some of them for the comparative analysis. Which type of segmentation techniques will be helpful for the better classifications. So these are some of the papers and their respective results. This is a proposed model. I have input some of the X-ray, I have given input to of X-ray images to train a data, and the pre-processing is done. Some of the filtration is done, and the images are resized. Here I have used Inception V3 as an encoder, and the rest of the segmentation pre-trained segmenting models like UNet, LinkNet, FPN, and the PSPNet. I have done the comparison among these output images, segmented images, which is generated from these models, and the comparison is done. So basically, there are 5 foundation architectures which I have used, that is UNet, LinkNet, PSPNet, FPN, and the Inception V3. So these are the steps of the proposed method, which I have already explained in the previous diagram. So these are the parameters. I have used a sequential model and learning rate is 0.0001. Adam optimizer is used. Batch size was 16. 100. I have trained my dataset till 100 epochs, and the loss values is dice loss is used, and for the evaluation purpose, IO score, F score, and dice coefficients is taken out, and evaluation is done, and the activation is done using ReLU and the sigmoid. ReLU at the sequential layer and the sigmoid at the dense layer. And the sprites are 2x2 and kernel size is 3x3. For this purpose, I have used the Montgomery County X-ray dataset. It contains 138 frontal chest X-ray images, out of which the 80 are normal cases and 58 are the TB cases. So that size of the dataset is very less. So augmentation is done to increase the efficiency of the process. These are The evaluation matrices IOU, intersection over union, dice coefficient, and F1 score. These are the matrices which is used for the segmentation purpose, which better give the accuracy rate. So these are the results. Here you can see in the left side of the graph, this is a result of the mean IOU score obtained by these types of pre-trained model, segmenting model. Here we can see that PSP net is giving a highest score and the loss is minimum using the PSP net segmenting model. And these are the matrices which is obtained. As you can see here, we can see that there is a execution time is more in PSP net, but for the medical treatment, execution time is not that important as per the accuracy, so that the patient's treatment can be done in a better way. So these are the graphs which I have obtained from the model 1, 2, 3, and 4. The above graphs is for the loss, and the below graphs are the mean IOU graph which I have obtained. So let's switch on the conclusion part. As the study explores that here the Inception V3 worked as a backbone encoder, and for the decoder purpose, I have used 4 types of pre-trained models like UNet, LinkNet, FPN, and the PSPNet. And what is obtained is the highest score is achieved by the PSPNet, and thus the comparison is done with it. Thank you. These are the references.
Okay. Why you have chosen Adam Optimizer? Yes, am I audible? Hello?
Yes, ma'am.
Yes, am I audible?
Yes, ma'am, you are.
Yes, I just asked you that why you have used or choose Adam Optimizer.
Sorry, ma'am. I just because this implementation is done very earlier, and after that I've done so many works, so I'm just not able to answer this.
Okay, and you, as you said, you have passed on the data for the training as well as testing purpose. So, in what ratio the data set was used for training purpose and the testing purpose?
70-30, ma'am.
70-30. Okay, okay, sure. Thank you.
Thank you, ma'am.
Thank you, ma'am. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter Albay Thomas with the paper titled Green Transformational Leadership Character Skill in Healthcare Organizations. Ma'am, if you're ready, then you may go ahead.
Yes, just give me 1 minute. I'm just sharing.
Sure.
Is it visible?
Yes, ma'am, it's visible.
Okay, thank you. Thank you for giving this opportunity to present my paper. My paper ID is 228, that is Green Transformation Leadership Characteristics in Healthcare Organization. And present myself, Dr. Albie Thomas, Assistant Professor, Symbiosis Institute of Health Sciences from Pune, India. So moving to this presentation, I would say I would like to share one story, how this topic was selected. Actually, this was part of my thesis where I was analyzing how the transformation in healthcare towards sustainability can be attained, and came to know that there is operation strategies, green ergonomics, ergoecology, workforce agility has been implemented in the healthcare, but we have to identify what are the leadership characteristics which is required for the healthcare managers so that they can lead to a green transformation. So in the study, the key authors are myself, Dr. Suresh M, and Dr. Sumati Kumaraswamy. So let's move to the abstract. This study, it mainly aims at establishing a conceptual model and identifying the characteristics for the GTL So I'll be using the term GTL for the green transformational leadership. So the main focus here was on the healthcare organization. So in order to identify the factors, we went through a literature study, and the factors were identified basically from the literature and later on was face validated by the healthcare expert. So these healthcare experts were of five experts from the hospital with more than 10 years of experience. And then we used a closed-ended questionnaires and scheduled interviews were used to gather the data. For this study, we used the mathematical modeling, that is the TISM, total interpretive structural modeling, and the micmac analysis. So the findings of the study showed that the independent factors were openness to new green ideas, clear vision, green knowledge, emotional intelligence, and the team building capacity. So how the study is going to help in societal implication or the managerial and practical implication is that this model can be implemented in the healthcare sector, in the Indian healthcare sector, because the respondents and also the study were mostly focused on the Indian hospitals. Moving to the introduction, we know that when we talk about healthcare, we always think about the hospital. So in the study, hospital was the main focus, and we know that around, if we are considering healthcare as a healthcare sector as an institution or a institutions, so we can see that it is the fifth most highest contribution. It contributes to the global emissions or the carbon footprint. So we know that the importance of having sustainability in healthcare and the importance of leadership to it. So leadership with the right rate is essential to encourage the organizational creativity and the green transformation. So what is green leaders? They helps to connect with their workforce in a way that it will promote the employees' propensity to look for the greener solutions. Moving to the literature review. In literature review, here I have emphasized on the definitions much more, because we have learned about transactional leadership, transformational leadership, but in these leadership kinds, the factor of organizational environment goals is missing, and that's how the term green transformational leadership was arrived uh, in the research. And this GTL is a leadership style whose major goal is to provide employers or the employees with a clear vision, inspiration, and motivation, while also meeting their developmental needs in order to achieve the organizational environmental goals. It also refers to the act of leaders who motivates the followers to achieve the environmental goals and inspire them to apply the sustainable practices. So these GTL leaders, they have the capacity to generate new knowledge and creative ideas so that it leads to a green innovation. So now let's see what are the research questions. In this study, mainly we focus on three questions, that is what, how, and why. The RQ1 is about in healthcare organization, what are the characteristics for GTL? How are the GTL characteristics interrelated with each other? And why they are why they are influencing each other? And can we prioritize these characteristics so that the managers will be able to know that which characteristics will be important for the implementation? So one of the characteristics is capacity to implement changes. Next is openness to green ideas. Third is clear vision. Fourth is green knowledge. Intellectual and social capabilities, emotional intelligence, inspirational motivation, individualized consideration, clear communication, and the last one is team building capacity. So as I said, for the methodology part, we have segregated as two. First session will be identifying the green transformation leadership characteristics using literature review and the expert's opinion and the sample size. And then we'll be modeling and prioritizing of the GTL characteristics. So in order to employ the TISM and MICMAC, we require a sample size of 20 to 30. And then we will be preparing a questionnaire. We will be analyzing the influence of factor 1 influencing the factor 2, factor 1 influencing the factor 3, and so on. So in order to comply with the ethical concern, we have taken ethical approval from the Amrita Institute. And later on, we went with a scheduled interview and asked the respondents to rate from 0 to 4 like its scale, where 0 refers to no and 1 to 4 refers to the least influence to the very high influence. Later on, once we get the responses, we create the initial reachability matrix, and later on final reachability matrix, and then there will be a partition where we'll be analyzing the transitive link, and the interaction matrix will be prepared, diagraph creation, and later on the diagraph creation, and then a TISM model will be developed, and based on the FRM we are working on the micmac analysis simultaneously, where we will analyze the driving and dependence power of these factors and create some graph and rank for the factors. And this is the model which is created. You can see that in level 7, that is the openness to new green ideas, clear vision, and green knowledge. These are the building block of this model and the key factors. And sorry. Okay, and you can see that capacity to implement changes is in the top of the TISM model, which refers to this factor will be influencing directly to the organization, and also any changes in other factors can influence the factor. This is also known as the independent factor. Then we move to the micmac analysis, where there will be micmac graph and micmac rank. So this is the graph. This graph will be divided into 4 zones, that is zone 1, zone 2, zone 3, and zone 4. In zone 1, it refers to the autonomous factor, that is the factor which is having low dependence and low driving power. For the study, there were no autonomous factors which were identified. And in zone 2, that is the dependent factors, which means that higher dependence and lower driving powers. You can see C8, that is individualized consideration, C9, that is clear communication, C7 inspirational motivation, and C1 capacity to implement changes are the dependent factors. And linkage factor is C5, that means the factor which is having high driving and high dependence factor, dependence power. And the independent factors, you can see independent factors are the factors which is having high driving power and least dependence power. And based on the driving and dependence power, we have created the rank. Here you can see that C2, C3, C4 is having the rank 1, which refers to these are the factors which managers, healthcare managers has to have a much focus, rather than the factors C1 that is ranked as the 7th.
Ma'am, I'm
Okay.
really sorry to disturb you, but I'd like to
Yes,
remind
yes,
you.
I'll just finish it right now. And discussion is about the importance of GTL. As we always talk about sustainability in healthcare as a theory, but then the practice is really the practice theory and practice is having a greater gap. So in the conclusion, it is said that green transformation leadership needs to be improved, helps in improving the green awareness, self-esteem, and effectiveness in the healthcare industry. So we require green transformational leaders for the healthcare organization to move towards a transformation. So this paper, it talks more about the application of TISM and micmac analysis in identifying the factors and the interrelationship of the factors. And the limitations and the future research direction is the limitation is the generalizability of the factors, and the future research direction could be we could expand this to different geographical location, and also we can try SEM and longitudinal studies, and also we can validate these studies using SEM technique, that is structural equation modeling. Thank you.
Okay. Any kind of such applications has been already developed anywhere? Have you studied those?
Yes, ma'am. Regarding green transformational leadership or the TISM method, ma'am?
Green transformation leadership?
No, ma'am. Actually, there is no conceptual model related to the green transformational leadership. There are theoretical papers which is related to it.
Okay, but no any such real-time application is there, right?
Yes, ma'am.
Okay, okay. Thank you.
Thank you so much.
Thank you, ma'am. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter Priyanka Bhatt with the paper titled Implications of Sentence Simplification in Improving the Quality of English Odia Machine Transfer Translation. Ma'am, if you're ready, then you may start with the presentation. Ma'am Priyanka. seems we don't have her in the session yet. We'll be moving on to the next paper presenter. Stephen, with the paper titled IoT-based heart monitoring using digital twin. So if you're ready, then you may start with the presentation.
Am I audible?
Yes, sir, you're audible.
Let me share the screen. So, hi, our paper is based on the topic IoT-based heart monitoring using digital twins, and it's presented by Stefan D'Souza. My co-authors are Dr. Naina, Samathis, and Dr. P. Jay. So, coming to the introduction of this paper, our, during these times we have seen an increase in cardiac-related health issues, and especially mental. And to solve this, the healthcare industry has seen various ways in solving this problem. One is the increase in the usage of different technologies to build different new and innovative medical devices. So coming to that aspect, we propose a solution where it uses IoT digital twin and deep learning technologies to create a system which can be used for uh, monitoring and classifying patients' cardiac data. So, keeping this in mind, our proposed system is designed based on four objectives. First is to design a robust IoT system for capturing real-time heart rate data. Second is to build an accurate digital twin which simulates the characteristics of the heart. This can then be further used for analysis. Developing a classification model to predict any abnormality in the user's heart. And the fourth one is building mobile application for a convenient and user-friendly way for the user to check his or her data. So coming to the system design, our system is broadly classified into four components. The first part is the data acquisition component, or the IoT part, where it uses different IoT sensors to capture the heart-related data in real time. For this instance, we have used the MAX 30102 sensor, which records the heart rate and the blood oxygen level of the user. And this is then connected to a module called the ESP32 module, which sends the data to the next component. The next component is the IoT hub and the digital twin exposed environment. So the data is then sent to the IoT hub, which collects data from all these sources and performs data pre-processing in this case. So one aspect of the IoT hub is it uses access tokens, where each component or each module is given one unique access token. So in this case, security is enabled, and the component is only able to send data to that particular IoT hub instance. After that, we have used a function app which translates this raw data into a readable JSON format, which then sends it to the digital twin environment. Over here, the digital twin environment shows the user all the real-time data which is being recorded. As an example, I can show that for one user at a particular timestamp, the heart rate is recorded over here and the SpO2 value is recorded here. So in this case, for each user, one digital twin instance is recorded. The next component is the machine learning or is the deep learning or the classification component, where it sees the ECG wave between the P and the T wave, the starting point and the ending point, and checks if this the ECG wave or ECG unit is a normal ECG wave or not. So for this deep learning model, we have used pre-trained VG16 CNN model, and we have trained it on 99,000 ECG images, and the classification is either normal or abnormal in this case. This classification model is then embedded in our next component, which is the user interface model. The user interface model gives a quick and easy way for a user to access his or her own heart rate data. So yeah, this gives an overview of the different components in the system. Coming to the results, these are the screenshots of the different components. So first we have see the digital twin. The next part is the IoT hub instance, where as you can see, the raw data is coming in at different timestamps, and each data is classified. So we have recorded the blood oxygen level, the heart rate of the user as we can. And this is a user interface where the user can see his or her own heart rate. So coming to our results, we have trained the classification model on available publicly available data set, which is the MIT BH arrhythmia data set, and we have tested it on a live test person using his ECG data. The results for the test data has shown a 98.37% accuracy for the CNN model, which can be increased on further fine-tuning the model and using a better and larger data set. So coming to the future enhancements of this system, we can integrate this into a tight fit, skin tight shot, which can be more user friendly and more comfortable for the patient in this case. And since it being more closer to the skin at all times, it can give an accurate reading for the different heart data. Larger data set, a larger data set of ECG images is also advantageous since it makes the CNN model more accurate in this case. Yeah, so in this case, we have proposed a system for an efficient health monitoring and classification for the cardiac patient.
Okay, which classifier have you used?
So we have used a pre-trained VGG16 CNN model, and we have built upon this model to take in the ECG images between the P and the T wave, and classifies it as abnormal or abnormal.
Okay. Yeah, that only I was asking which classification model have you used?
CNN based model,
Okay.
convolution neural network.
Okay. Okay. Thank you.
Thank you, sir. Thank you, ma'am. We'll be proceeding with the next paper presentation. I'd like to invite Bhumika with their paper titled Leveraging Graph Convolutional Networks for Heart Disease Detection with Limited and Imbalanced Data, a focus on interpretability. Ma'am, if you're ready, then you may go ahead.
Yes, ma'am, 1 second. Ma'am, is my slide visible?
Yes, ma'am, it's visible.
Good evening to everyone present here. Today, I will be presenting our research leveraging graph neural networks for leveraging graph convolutional networks for heart disease detection with limited and imbalanced data, a focus on interpretability. I'm Bhumika, and I will be representing on behalf of my team. We are all third-year BTech students in PES University. Heart disease is one of the leading causes of death globally, creating a critical need for accurate and interpretable predictive models. However, most data sets for heart disease are imbalanced, which reduces the reliability of predictions, especially for high-risk individuals. Our work aims to address these issues using graph convolutional networks enhanced by explainable AI techniques to improve accuracy and transparency. We worked with a dataset containing of 253,680 instances with 21 features. Due to the class imbalance, only 10% of individuals were diagnosed with heart disease. We employed DB-scan clustering to reduce the dataset to 1,200 representative samples with which we worked on. Pre-processing include feature scaling and stratified splitting to maintain class proportions in the training and testing sets. Our model uses GCN or graph convolutional networks to handle the complexity of relationships in the patient data. We constructed the graph using KNN algorithm, and the GCN has an input layer of 21 units. It has two hidden layers of 60 and 19 units, and an output layer for binary classification to detect whether heart disease is present or not. We had dropout layers to ensure overfitting of the model doesn't happen. And at the same time, we used ReLU activation function and Adam optimizer. We compared across four imbalanced data handling technique strategies, which is Boost GNN, SMORT, weighted loss function, and curriculum learning. In Boost GNN, we used 10 classifiers and we trained it for 20 epochs each. Each classifier iteratively improved on the previous classifier's mistakes by increasing the weights on the previously misclassified example. In synthetic minority oversampling technique, we synthetically generated the data for the minority classes in order to give a more balanced training for the model. In weighted loss function, we increase the weight of the minority class based on the class imbalance present in the data set. For curriculum learning, we made sure the easier patterns were learned earlier and the difficult patterns were learned later by progressively guiding the model's focus during training by dynamically adjusting the loss weights. For explainable AI, we have used SHARP. SHARP provides both summary plot as well as decision plot. In the summary plot, it provides a more general understanding of the feature importance across the entire data set. So it highlights which features have more significant importance when considering the whole data set. While in decision plot, it offers a more individual level understanding by explaining predictions for specific instances. It shows how each feature contributes to a single prediction, and it also quantifies the amount of importance that each feature is creating to the prediction. This combination of both global and local interpretability makes SHARP an ideal choice for enhancing model transparency and trust in healthcare settings. These are the results from our paper. So when we did a comparison across them, Boost GNN outperforms all the other techniques with an accuracy of 68.7% and an F1 score of 0.36 for the minority class. Although you can see that SMORT excels really well in detecting the minority classes, having an F1 score of 0.57, but it negatively impacts the majority class identification, due to which you can see that the accuracy of SMORT has dropped down to 59%. Yeah, so the feature importance analysis using SHARP summary plot. So from this, we can understand that the key features that affect the heart disease detection is general health, age, and stroke. Over here, general health values range from 1 to 5, where 1 is excellent health and 5 is very poor health. And stroke is like a binary variable which mentions whether the person has a past history of stroke or not. Least important feature is any healthcare. Any healthcare refers to if the patient has any health insurance or not. Red values actually represent the higher values for that feature, and blue values represent the lower values for that feature. So in a general trend across features, we can see that higher values for the feature tend to increase the risk of heart prediction. Heart disease prediction. And we also understand the socio-economic and lifestyle impacts such as income or education also have significant impact when we are considering heart disease prediction, but they are very contextual dependent. So it might change based on the other features' importance. And basically, sharp summary plot gives us a more global trend insight into the whole data set, while sharp decision plot is more like an individual instance specific one. So we can see for this particular instance, general health, high BP, and physical activity have the highest influence. As we can see, physical activity had a very moderate importance when we were considering the general trend of the data. But for this particular instance, it has a very significant importance. That is why it's important to understand both the decision plot and the summary plot before coming into conclusive evidence for any healthcare worker. So the conclusion is that Boost GNN achieves the best performance across all the comparative techniques that we have chosen. Sharp improves understanding and trust in prediction. The future directions that we look forward is we want to work with larger data sets with larger computational resources. The reason why we use a subset of data set was because GNN is computationally expensive, and we had to work with the limited computational resources that we had at the time. And so we want to see how this might change or whether this will hold when we increase the size of the data set and we work with larger computational resources. Another thing that we would like to look into is trying more interpretable models and to see if there are better imbalanced data handling techniques and make the model more accurate, because the performance of the model is still not in the 90% range, which is very important when we are considering healthcare as a sector for accuracy to be very important. So thank you very much. You can ask any questions.
Yes. Any latest research paper have you studied for this?
Yes, ma'am. The
Yep.
latest research paper we read was like in 2024, which was using graph convolutional networks for health disease prediction. That is the reason we knew that neural networks work comparatively better than all ML models, because it can understand the more intricate complex relationship data in a better manner. And even the whole method of using Boost, GNN, and curriculum learning, all of them are recent advances in 2024.
Okay, but still the accuracy is only 68%, right?
Yes,
0.68
ma'am,
is
that
what?
is majorly because we were working with a very small data set. In the papers that we read, like I think curriculum learning had reached up to 96% accuracy, but they had grants from NVIDIA, so they could work it on larger scale.
Okay, okay. Okay, no problem. Thank you.
Thank you, ma'am.
Thank you, ma'am. We'll be proceeding with the next paper presentation. I'd like to invite paper presenter Karen Jane with the paper titled On the Analysis of Swarm Robotics in the Sensor-Based Environmental Monitoring for Sustainable Poultry Farming. Ma'am, if you're ready, then you may go ahead.
Yeah, hi. Am I audible?
Yes, ma'am, you're audible.
I'll share my screen now. Let me know when you can see my screen.
Yes, ma'am, it's visible.
Okay, so good afternoon, everyone. I'm Karen, and I'm excited to present our work on swarm robotics and sensor-based environmental monitoring for sustainable poultry farming. And what we're trying to do is leverage the Firefly algorithm to address pressing challenges in the poultry industry. And we want to do early disease detection. So let's move on to the next slide. So here's a quick overview of our presentation today. We'll start with an introduction and then go into the inspiration behind the work, move through the aims, background, and methodology, and finally conclude with our results, analysis, and future directions as well. So the poultry industry is one of the largest producers of meat and eggs. Poultry itself refers to any bird rearing industry, which is for production of meat, eggs, and feathers. And the main sector within the poultry industry talks about chicken. So they actually produce millions of tons of meat and eggs annually. But the problem over here is the health conditions can be a bit crucial. And if there are diseases present within the flock, at that point you would have to either look at methods of mass culling, or if there's a cure, then that would be presented. But most of these diseases Normally, once you've given them a medication, you cannot push most of the flock to market after that. So some of the traditional monitoring systems include the ceiling mounted sensors, which are inaccurate because they cannot capture the ground level environmental variables. Ground level as in where the chicken really are. It takes overview from height difference of maybe 3 meters above the ground. And one of the points I can tell you with the discrepancy is where ammonia, for example, is one of the parameters that we're reading. Ammonia is a lighter gas, so the readings at the ceiling level would be at least 10% higher, just because ammonia rises over most of the other gases. And on the other hand, CO2 is a heavier gas. So the ground level readings would be much higher. So the ceiling sensors wouldn't accurately capture what the actual reading is at the ground level. And both elevated ammonia and CO2 levels at ground level can lead to respiratory issues in poultry itself. So the ceiling mounted sensors might underreport these values. Other things that we could look out for is the higher ground level humidity, which increases the risk of bacterial growth and wet litter problems. So some of the diseases that we talk about in terms of poultry health is like the avian flu or salmonella as well. And both of these can be risky if not treated at the right time. So let's move on to the next slide. Okay, so I mentioned we have a discrepancy in the readings. So normally if a discrepancy is noted, what would happen is someone would manually go in and then look through the readings, like take extra equipment, take more readings over a day or two, and then see if the readings are actually different than the normal threshold. Now, this would increase the delay or the risk, the delay in time that you take to diagnose a disease in the farm. And another thing that they would normally check is the number of chicken which have died per hour. But if you're doing this at a delayed stage, you wouldn't know if, okay, there was a disease present at, stage 1, and it could have been cured, but then all of these procedures delayed it to maybe stage 3 or 4, and now suddenly we're looking at a mass culling. For example, in 2022 itself, a factory in the US had to cull around 5.3 million of their flock just because they detected a disease a little too late. So our vision is to automate these processes, improving flock health and reducing ecological impacts through data-driven monitoring. Let's go into our aims and objectives. Our goal is to develop a swarm robotics solution for ground level monitoring, integrating fitness functions to guide navigation while ensuring adaptability in real time. So what we want to do is we want to try and use a multi-robot approach. There are several existing single robot approaches that are being actively tested. But the problem with the single robot approach is that the poultry houses are quite large often. And for one robot to traverse the whole poultry house versus multiple low-cost robots, the trade-off is very clear. If you have multiple low-cost robots, maybe the cost of buying one robot would be still much higher. And you would have constant monitoring of most of the regions than only of one region at a time. So here's a little bit of background on what we're talking about. So in swarm robotics, we have 3 main principles. One is decentralization. So every robot tries to work on local rules, and these local rules then try and get emergent behavior. So local rules normally have very simple behavior, as in I follow the light, or in the case of ants, for example, they'll follow the pheromones that have been laid about. But when we look at it on a holistic view, there's a lot of emergent behavior where you would notice that most of the pheromones, which in the case of an ant algorithm, most of the pheromones which remain on a single area actually lead to the best solution or lead towards food in case of the bio processes that we see. Another one is scalability. So by increasing the number of robots, we still don't increase the system complexity itself because the robots are still doing the same local simple behavior. And finally, robustness. So resilient to failures. What we're talking about here is even if one robot fails within the whole system, the other robots should still continue working as per normal conditions. And the failed robot, although it might make an impact to the global reading itself, but the reading should not be significantly impacted because it's just one out of maybe 10 or 15 robots. Now let's go into the key features of our Firefly algorithm, and that's the algorithm that we'll be using for implementation. The Firefly algorithm has, so the key way that we can look at it is a Firefly always glows, and the brightness is the attractiveness of a Firefly. And there's another thing about the Firefly as well. It has not only intensity, but the rate at which it glows because it's a blinking light. And then there's the attraction between fireflies depending on the brightness and the distance. So we tend to look at if there's something bright in front of us versus there's something equally bright but far away from us, our perception is that the one which is far away from us doesn't look as bright. So that's the decay in brightness or decay in light intensity itself that we would perceive. And that's a key feature as well in Firefly algorithm that helps more localized behavior to be seen than only global behavior. So this encourages convergence while having a good balance between whether we go towards a global best or a local best. So we designed a system combining robots, sensors, and controllers. And the Firefly algorithm's fitness function actually just incorporates the sensor deviations and the robot distances. So here we can see the distance weight is talking about how far apart the robots are, whereas the sensor deviations talk about how far they have moved from the regular thresholds. And for the simulation itself, we used Gazebo and Arvis, which are ROS-based tools to test the robot's navigation in a controlled environment. And I can show you how it goes. So these are all the sensors that we used. We used the MQ135 for ammonia, 137 for carbon dioxide, and the DHT sensors for the temperature and humidity. We wanted to make it as low cost as possible, and we found that these sensors do have a good level of accuracy for the use because when we try and increase the number of robots, the robots collectively improve the accuracy than as a single unit itself. And here are some of the hyperparameters. So yes, first of all, the brightness was defined by the deviations of the sensors itself. And these were then weighted using the hyperparameters. So alpha defines the step, the size of the step that you take towards the robots with the higher fitness. The B naught is the initial attractiveness of the robot. And gamma is how far away or the light decay that I was talking about earlier, how based on what distance would the brightness seem to be less or more apparent. And through careful testing, we found that these are the most optimized parameters that we can use for our given test scenarios. So for the step size of 0.75, we achieved a balance between convergence speed and overshooting. When we reduced the step size, the problem was we had slower convergence. But when we increased it, we kept going beyond the global best and we would never converge at any point. That's where we finally got to a 0.75 value here. For the B naught value, we ensured that there was a strong initial attraction for quicker convergence initially before they start moving out away from each other. And then for the gamma rate or the rate of decay, we didn't make it too high because we wanted to maintain a little bit of global exploration as well while looking for the local optima. And there were two types of prototypes that we built. One of the prototypes used a Rosbot 2 Pro, and that had a LiDAR sensor. And the LiDAR sensor over there was the one used for object detection and obstacle avoidance, so that we don't hurt any of the flock who would be moving around, and that made the robot suitable for a dynamic environment. For another low-cost implementation that we were trying to do, because we realized that using any of these existing bases would significantly increase the prices of the robots. So for the obstacle avoidance on the other ones, we started using the ultrasonic sensors, which did show a fairly reactive movement towards a real environment. So this was how the result looked. The robots effectively navigated through the gazebo environment with all the optimized parameters. Fitness-based movement guided robots through high priority regions for monitoring. And the high values of B0 and A sometimes did cause collisions initially when we were testing for much higher values. So when we kept the alpha size to be around 1.2, 1.3, we saw collisions, and the same for B0. Although initially it would look like the algorithm was converging to a good solution, but then suddenly we saw that, okay, it's changing. So let's go to the next slide. Okay, so this is the robot that we had tried to test on. This is for the low-cost implementation that we did individually. What we did was we bought these little microelectronics, and for the chassis, we just used the regular RC car chassis. So that we could drop the prices a lot, and we could see that, okay, if the robot is damaged, we can still replace things without causing a high cost, because that's the whole point of giving these to poultry farmers. So in conclusion, what we saw is our system successfully integrated swarm robotics with sensor-based monitoring to address critical challenges. And now some of our future work includes integrating machine learning models for task prioritization, developing heterogeneous robot swarms, and also enhancing energy efficiency for sustainability. And one more thing was we would use these same ANNs, for example, to improve the hyperparameter definition to make it more dynamic, because as I said earlier, initially it looked like one of the higher parameters did converge well or even better than the ones that we had a result of. But then it's just that as time went by, as the environment did start changing a little more, the values needed to be dropped. So this could be taught to an ANN. And so that's the main limitation that we initially noticed, that having a fixed nature for parameters would not generalize to all farm layouts. And another conclusion is that our fitness function accurately guided the robots. Accuracy that we defined was based on the number of robots that go to a high labeled priority area. So for this, we had labeled areas with certain. So what we did was we were trying to simulate different reading values, because we couldn't constantly in a simulation environment. What we did was we made these channels which would publish randomized messages, or supposedly randomized messages that we would set to say, okay, so and so region is now the high priority, and we would then tend to see, before the priority changes, would the robots converge to that region first, and after converging to that region, when we change the area, would it then go to another area where the priority was now higher. One of the final things that I would mention about this project is that it was the runner-up for the James Dyson Award in the UAE, and it was also the winner of the best final year project for the university itself. So thank you. If you have any questions, I might be happy to take them right now.
Any another application already developed for the swarm robotics, which you already know or you have studied?
Could you repeat that?
Is this the first model which you have prepared for the Swan robotics, or is there any another application which is already there and you have studied that also?
So for poultry farming itself, this is the only one that I'm using, but for swarm robotics itself, we've been doing other work in trying to analyze if this can be used for agricultural health, for identifying, for example, plant leaves, if the discoloration on them could be leading to disease. But most of the applications that we've been looking at are towards disease detection.
Okay. Okay, thank you.
Thank you.
Thank you, ma'am. That was the last presentation for the session. I sincerely thank our authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTCS 2024. I'd also like to thank our session chair. Just a second. I'd like to thank our session chair, Professor Chetali Shivale, for chairing this session, a token to chair on behalf of Team ICTCS and Global Knowledge Research Foundation. Thank you for your valuable presence, ma'am.
Yes. Yes, thank you, ma'am.
Just before we end the session, I'd like for everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.